In this video, we're going to show that the volume of a sphere with radius r is 4/3 pi r cubed. This is a familiar formula, but we're going to use calculus to actually derive it. We'll start with a circle. X squared plus y squared equals r squared. Now this is a circle centered at the origin with radius r. Solving for y squared becomes r squared minus x squared, and taking square roots of both sides, y equals plus or minus square root of r squared minus x squared. The positive part, square root of r squared minus x squared, is the upper semicircle centered at the origin with radius r. So here's what it looks like. Upper semicircle centered at the origin, radius r. Now if we rotate this semicircle about the x-axis 360 degrees, this region, this area enclosed by the x-axis and the semicircle about the x-axis, we actually end up with a sphere of radius r. So this is what it looks like. Any sphere with radius r has the same volume. So we're going to concentrate on this sphere that we generate by rotating this region, and we're going to use a technique called the disk method to find the volume of the sphere. So this is minus r to r. I'm going to pick a typical x between minus r and r. Keep track of this vertical piece of the area. And remember, this is the function y equals to the square root of r squared minus x squared. As we rotate this 360 degrees, we end up with a little disk that looks like this. If we put it sideways, here's what it looks like. Kind of like that. Now, the radius of this disk is y. It's simply the distance from the x-axis up to here, which is the y coordinate, and we're going to give it a little bit of thickness, very, very small. We call it dx. So the volume of the small disk is pi times y squared, that's the area of the base, times the height, the little thickness, dx. Expressing this as a function of x, since y equals to square root of r squared minus x squared, squaring it gives us r squared minus x squared dx. So this is a very, very small part of the volume. When we sum up all these pieces for every x, the integral from minus r to r will give us the exact volume. So this is pi times r squared minus x squared. So all we have to do now is to evaluate this definite integral. Let's go ahead and do that. Remember, r is a constant, so the integral of r squared is r squared x. The integral of x squared is 1/3 x cubed. Then we have a pi in the front, and we evaluate this from minus r to r. Just be careful plugging these in, and we'll get the right answer. So pi times, plugging in r for x, r squared times r is r cubed. R cubed times 1/3 is 1/3 r cubed. That's the first part. Minus, now when we plug in minus r for x, r squared times minus r is minus r cubed. Minus r cubed is minus r cubed with a minus in front, gives us a plus 1/3 r cubed. And so this is pi times the first set of parentheses give us 2/3 r cubed minus a negative 2/3 r cubed. Adding this up, we get the answer, which is 4/3 pi r cubed as the volume of a sphere with radius